Hi everybody, this is Mr. Folly. Happy homecoming weekend everybody. Hopefully you're having a blast either doing homecoming stuff or hating homecoming and doing something fun outside of homecoming things. I can speak. This is Excel Podcast 5.2. It is not Podcast 5.2, it is Podcast 4.1. I wonder how I did that. But it is 4.1, so sorry about that. We do the definition of a mole, molar mass, law of definite proportions, and density of a gas. One other thing I want to tell you is, here's your extra credit homework. Ooh, get so excited. If you Google making your own mole, there is a pattern where you can make this cheesy little critter that looks like this. A mole is also a critter. A little critter that's like a rat, and there's a couple of my room as examples, and you can make your own mole. And if you make your own mole, you get extra credit if it's got a really bad mole pun name that's just terrible. So, for example, someone always does a little putting green with a flag and says, "Oh, look, here's my mole. He's a mole in one." Ah, ha, 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 ha. Or then someone puts a little halo over him. He's holy moly. Ah, ha, ha. So you have to find it. You got to Google it or whatever your favorite search engine is. Find the pattern for it and make it. It has to be made out of fabric. It cannot be made out of newspaper or whatever it is. So those of you out there that are interested in this, tell your ability to start making a mole with a bad pun name. That being said, let's learn a little mole stuff. A mole is a clustered unit. Eggs are grouped by the dozen. Why? It's a nice handy amount for whatever it is. Bottle rockets. Yay, I love living in Indiana. We get our bottle rockets all the time, 365 days a year, by the gross. Because 12 bottle rockets isn't enough, you need to buy your bottle rockets in groups of 144. Paper is grouped by the ream, 500. Now maybe you've heard that donuts, there's a baker's dozen, which is 13. There is a printer's ream that is 512. So you get a little extra kicker if you find some place that'll give you a printer's ream of paper. That's the packages of paper that you get. Now, because paper is smaller, we use a bigger number when we count them, 500 or 512, which really is going to be 500. So these particles are so small. Remember, atoms are so unbelievably small, we can't really ever see them without microscopes that make things so small I barely believe it's there. So they're so small that a mole is 6.02 times 10 to the 23rd. That means 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's a lot. That's a lot. Okay, that number was discovered by Amedeo Avogadro and is called Avogadro's number. So you need to have this number memorized, and you will pretty shortly just from the work we're going to do, and know that it's Avogadro's number. So particles are so small, a mole is this. So what's a particle? A particle is a fancy word for an atom, or a molecule, or a formula unit. So what's an atom? One element. What's a molecule? I'm going to say any compound. And a formula unit is, if you want to get really picky, it's for ionic compounds only. Now, we've mentioned this once or twice before, but ionic compounds form lattices. Remember, so if I'm an X, I'm bonded to a Y here, and a Y here, and a Y here, and a Y here, and fading back, there's a Y. So one X has like 5 bonds or more, and each Y then has an X attached to it in all these different ways, so it gets really confusing and monstrously large and all these other things. But a molecule, like water is a molecule, water looks like Mickey Mouse, a definite beginning and definite ending, whereas this nightmare with all this stuff going on here, there, everywhere, it's got the little box things that move from one spot to the other, and it's got this weird shape. Formula units are reduced structures. But remember, you can use a molecule to represent any of them. A molecule, of course, is a molecular compound, which would start with a nonmetal. But molecules are also used for formula units, and they're assumed that to be used interchangeably. So there you go. So a mole of gas. A mole of gas is the same size no matter the gas. That's true. Why? Particles are so small compared to the container. All right, so sometimes the size of the particle really matters. So let's pretend I've got a car and I want to try and fit 9 people in the car. 9 people, does it matter how big the people are? Most definitely. If I have 9 little babies, wah, wah, they'll all fit in there. Wah, wah. Okay. And then you've got a car that smells like diaper. Okay, which is not a good thing. Wait till you do your little health project. Not that they make you smell diaper in your health project, but you get the idea. So the size of the person really matters. So I have 9 people, or if I have 9 giant people, say professional athletes, not that they're giants, but you get the idea. 9 professional athletes, it's a lot more difficult. So because the size of the container is relatively small compared to the size of a person, it matters the size of, you can fit a certain number of people in a car. Let's say we're talking about the state of Indiana. If I'm trying to fit 9 people into the state of Indiana, doesn't matter if they're babies or giant people. They could be huge, enormous, wonderful, by the way, my house, huge, enormous 35-foot tall people, and I could put 35-foot tall people in all of these wonderful places in Indiana, and they still, it wouldn't matter how big they are, right? It wouldn't matter how big they are at all. So because particles are so small that it doesn't really matter, you can fit the same number of particles into the container. Okay. Guess how many particles are in a mole of gas? 6.02 E23 particles are in a mole of gas. Particles? Particles. So the things would probably be molecules or atoms. And since I'm on the topic, Knopf Coolbrith H and Knopf Coolbrith hat. Coolbrith hat. All of these guys would be molecules because they're bonded to each other. Okay, they're not atoms because there's 2 of them. A mole of gas is 6.0 10 to the 23rd molecules, but a mole of gas is also 22.4 liters. It takes that up exactly that much if it's at STP. By the way, we're always going to be at STP for 2008. In 2009, I teach you how not to be at STP, but right now we're at STP. STP stands for standard. It's our base. It's our standard, our basic temperature, and our basic pressure. Our standard temperature is 0 degrees Celsius, which is dumb, but that's what it is. 0 degrees Celsius is chilly. That's cold. Water's freezing. Why would you do that? Room temperature is 25 degrees Celsius. That's my preferred one, but no. We've got to make it cold. 1 atmosphere is a unit of pressure, and 1 atmosphere is air pressure at sea level. So if you've ever flown in an airplane, they make you chew gum or swallow or yawn or whatever it is so your ears don't explode. That's because there's a different pressure as you go up in the air. So this way, and that pressure, your head is equalizing the pressure when you chew gum or whatever it is that you do to get rid of your ears from exploding. If we're not at STP, otherwise, let me get rid of otherwise, not at STP, then we don't know the volume of a mole. But again, we'll always be at STP, so that's nice. Mass of a mole. So right now we've got volume of a mole. Now we're doing mass of a mole. It depends on the atom or molecule. This number right here, whoa, harder to read. The bottom number, the one with the decimal, is the mass of a mole from the periodic table. So nitrogen is, and just so you know, we're going to pull 2 decimal places all the time. So if I wanted to know what the moles of N2 is, since my periodic table here says nitrogen is 14.01 times 2 because it's diatomic, I would get 28.02, and mass's unit is grams. So my way of remembering how to find the mass of a mole is I say little g stands for grams and little g stands for go to the periodic table. How corny and awful is that? But that's what it is. If I want to do NH3, which is ammonia, you should know pretty darn soon, right now, that ammonia's formula is NH3. It's a common cleaning agent and used in chemistry a ton. So ammonia is NH3, so we have 1 nitrogen, 14.01, plus 3 hydrogens. 3 times 1.01. So that would be 3.03, so 17.04 is the molar mass of ammonia. The biggest compound I can think of to make out of this would be HNO3. So hydrogen, and again, these are from your periodic table. So if you look at your periodic table, you have numbers that are either exactly like or similar to this. So HNO3 would be 1.01. I'm going to do the column addition now, plus 14.01, just because I ran out of room. Plus, okay, 15.9994 means oxygen is 16.00. We use oxygen so much doing these things, you're going to learn your 16 multiplication tables pretty darn quickly. 16 times 3 is 48.00. So carrying so hard, 63.02 grams per mole. And again, I put grams, but it's really going to be grams per mole. Okay. There's another unit for the mass of a mole that's sometimes used. Because we say this is per mole, well, what if you want to know the actual mass of one molecule or one atom of it? You don't have to use grams per mole. You can use AMU, which is the atomic mass unit. And really what happens is you just kind of do a little fudge factor and say, we'll make the units atomic mass units, and that way we'll say what it is. Because really, the mass of one molecule of nitrogen is unbelievably small. So it's such a small number. You know, whenever we carry those exponents around, the e to the negative 20s, the numbers just aren't mathematically good for us to use. They don't. Our mind doesn't wrap around them very well. So again, mass of a mole is in grams most of the time, or AMUs. It'll be grams most of the time. Oh, mass has annoying names. We have a gram atomic mass. That would be if something is made out of atoms. This would be elements. By the way, it would be not diatomic elements. Gram molecular mass would be non-metal compounds or diatomics. And we usually let ionics kind of sneak in here. But really, ionic compounds, which are metals, right, are metal, and then non-metals, yeah. We let these guys sneak in here because really they're gram formula masses. But we pay so little attention to the gram formula masses and just kind of ignore it and just call things molecules and just let it slide. So that's about it. So let's see if we can a couple more molar masses. NH4 taken twice, SO4. Woo! To do this, N equals, how many N's do I have? I have one N here, but times 2. So 2 times 14.01 is 28.02. I have 8 hydrogens. So H equals 8. I'm sorry, I sadly have a lot of these molar masses memorized. Get out your periodic tables. Periodic table. Look for hydrogen. Hydrogen in your periodic table says 1.008. To 2 decimal places would be 1.01. Sulfur. I have 1 sulfur. I go to the periodic table. I see there's a 16 and a 32.06. I'm always going to use the one with the decimal. So it's 1 times 32.06 is, got your calculators? And then an oxygen, I have 4 times, check the periodic table, 16.00, 64. Add them all up. Ooh, more carrying. 6, 1. Oh, 6 plus 8 is 14. 22. Carry a 2, that's 4. That's 7. 132.16. I would be amazed if that was right. Grams per mole. O2, just remember oxygen. So if I put the word oxygen, you should know that oxygen equals O2. 16 times 2 is 32. I guess I just needed another one to do this. Be sure you round it 2, count them 2 decimal places. Compounds have constant subscripts. This is called the law of definite composition. Woo, I'd know that one. Law of definite composition says that compounds have constant subscripts. It indicates that atoms are indivisible. Star, 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 star. They are for us. If I'm a super duper nuclear chemist, if you're going to the nuclear talks on Tuesdays, you know that splitting atoms is where we get a lot of our nuclear energy. 20% of the energy in Illinois is what someone wrote in their paper. Comes from nuclear power. This law of definite composition also lets us find the mass of a mole, since each molecule has the same formula. So imagine if water has, it's got H's and O's in it. Now, when we go to the periodic table, we count on there being exactly 2 H's and exactly 1 O. What if, there's some water that's H3O, and there's some water that's H2.143O, 1.447. No, that messes it up. It has to be exactly whole numbers and exactly the same all of the time. So you need to know that there's a law of definite composition, which means the subscripts are constant. The last thing we can do pretty easily is density of gas. So density of a gas is love. Oh, love. Why is it love again? Density is a big heart with a knife through it. Hey, okay. If I have a mole of some gas, can I find the mass of a mole? Mass is measured in grams. Little g stands for grams, and little g stands for go to the periodic table. Can I find the volume of a mole? Gas, only if it's a gas, at STP. Oh, yeah. You better believe it. So what is the density of carbon dioxide at STP? So what I'm going to do is I'm going to find the mass of carbon dioxide. Mass. So carbon dioxide is CO2. So it's 12.01 from the periodic table plus 16 times 2 is 32. So my mass is 44.01 over, that's grams, over 22.4 liters. Now, density is a constant. So no matter what you have, it's always going to be a ratio of mass over volume. So as long as I choose the mass of a mole and the volume of a mole, then I will actually know what the mass and volume numbers are. So as long as I think of it as being a mole, I'll get it. And remember, density is constant. So even if I don't have a mole, once I figure out the density of a mole of gas, that's also the density of half a mole of gas, or 35 grams of a gas, or whatever it is, because density is a constant. So 44.01 divided by 22.4 is about 2, but let's see what Mr. Calculator tells us for sure. 1.96. I use 3 sig figs. Grams per liter. Notice I need a mass unit and a volume unit. Will carbon dioxide float or sink on fluorine gas? Fluorine. The formula for fluorine is F. Skirtich knows that, although he thinks it's F minus. But it's diatomic, so it's F2. So the density of fluorine gas is, look at fluorine. Fluorine is 19.00. 2 of them would be 38 over 22. Which would be 38 divided by 22.4. 1.70 grams per liter. So will carbon dioxide float or sink? Carbon dioxide is 1.96. Fluorine is 1.70. CO2 will sink on fluorine because it is more dense. More dense things sink. Now xenon, I need to look at my periodic table for xenon. Now is xenon diatomic? Novkobri. No, there's no X's in there. So xenon is 131.29 over 22.4, which is a lot more than 1.96, I can tell you that, but just to be crazy little calculator fiends, I get 5.86 grams per liter. So will carbon dioxide float or sink on xenon? Carbon dioxide will float on xenon because its density is less. The next podcast deals a little more with math, and let me tell you something. The importance of moles, you may think, oh, it's a goofy little word. My wife is a CPA, which is an accountant, and she took chemistry and did well in it, but remembers nothing about chemistry, thinks it's useless and pointless. Some of you might think that, but don't say that to me. And she remembers about chemistry. All she remembers about chemistry is always go through moles. That's how important it is. She remembers one thing, always go through moles. Nothing else, always go through moles. And always have fun on homecoming weekend. And if you're hating the homecoming activities, you better have fun doing something else. Have a great weekend, and I will see you on Wednesday.